So you guys saw about Newton's third law of motion, how Newton's third law actually is helpful for us, and few practical examples, correct? Okay, so now see, imagine, let's say you have a gun. Okay, let's say you have a gun, and then let's say you fire a gun. So what happens? So the bullet moves forward, and the recoiling of the gun happens backwards, correct? This is the example what we give for Newton's third law, right? See, in this case, see, the bullet is moving with some momentum, right? It has a mass, it has a velocity, some momentum. Now, the gun recoils back with certain momentum, correct? See, momentum, we can call it as the force into whatever the small amount of time it's happening, correct? So, force into that. Here, as the bullet is moving forward with some momentum and the gun is recoiling back with some momentum, what we say is the total momentum of the whole system is conserved. Because see, what does Newton's third law states? The force equal and opposite, correct? So as the bullet is moving forward, the same force the gun recoils back. The only difference here is the mass is different and the velocity is different. Whereas the total momentum should remain the same. Okay, so this is what we call as conservation of linear momentum. Okay, see, why linear momentum? You will see in the later chapters you have one more thing called as angular momentum. We'll come to that part later. So for now, remember, this is conservation of linear momentum. See, this is true for almost all the objects where whatever you see. For example, rocket. See, as the rocket, it should have a thrust, right? It should have a thrust. As the rocket is moving up, technically it's pushing the ground down, correct? Newton's third law of motion. If the rocket has to move up, that means it should put a force on the ground and go up. See, here also, the whole conservation of momentum is always true. Okay, like the mass of the rocket and the velocity, so that momentum, whatever you have, that is equal to the momentum of the ground. Okay, so that is equal to the momentum of the ground. So in this case, whenever we say there is conservation of momentum, so it can be any type of collisions also. For example, take an example of billiards ball. Okay, so let's say you're playing billiards or what we call as pool. So you hit a ball with a white ball. Okay, now what happens? As there is collision, this moves with the momentum, correct? Right, so the next ball moves with the momentum. So in this case also, the initial momentum of the ball, that is what you're hitting, it goes in, okay, let's say you're hitting the white ball. The white ball goes and hits the red ball, let's say. Now, the initial momentum of the red ball and the initial momentum of the white ball, if you think about this is the initial momentum of the system. Next, as the white ball comes and collides with the red ball, now the red ball moves forward. So the final momentum of the system, so the initial momentum and final momentum, these two are conserved, what we call. Okay, so take an example. So let's try to do it mathematically. See, let's say PA is the initial momentum. Okay, and PB is the initial momentum of, let's say, two objects A and B. Okay, two objects A and B. Now, see, let's say A and B, they collided and then it moves with a different momentum. So let's call that as PA dash and PB dash. Understood? So here, see, according to Newton's third law of motion, the force equal and opposite, correct? So FAB should be equal to minus FBA, right? Minus FBA. So if you look at this here, see what we get is PA minus PA dash. This is nothing but the change in the momentum. So PA minus PA dash, that should be equal to minus of PB dash minus PB, the change in the momentum. Correct? So the change in the momentum of particle A or object A and change in the momentum of object B. Now remember, according to Newton's third law, it should be minus. So we put a minus. So if you transpose them, you will get PA plus PV is equal to PA dash plus PV dash. That is, the momentum, the initial momentum of the object is always equal to the final momentum of the object. Understood? So this is what we say, that the whole conservation of momentum is true for any object. Okay? So this is true not just for macroscopic object. See, macroscopic object, like what we were giving the example of the rocket and the bullet and the billiards. Not only that, it's true even for a microscopic level. Like for example, see, there is one thing happens what we call as pair production. Okay, so what you have is you have a nucleus and a photon. So a photon comes and hits the nucleus. A photon has a momentum. So that comes and hits the nucleus. Now two particles, they eject. Okay, one electron and one more positron. Positron is what? It's nothing but a positive electron. Okay, now the initial momentum of the photon and the final momentum of the pair of those two proton and a positron and the electron, the whole momentum is conserved here. Okay, so this is what we call as pair production. Anyway, you'll study about pair production later. But the point is, even in a microscopic level also, the conservation of linear momentum holds good. Understood? So a few more examples I can give. In the next video, you will see one.